Hello, everyone. Our solution is called SolarRoot. It tackles water waste, energy production, and use of land.
Solar growth puts farmland at risk.
In the capital region, there are several large-scale solar projects in the works that'll transform thousands of acres of farmland into fields of steel and metal.
We are very concerned about the rollout of these renewables.
Money's come in and taken over, and we have no say. It's taken our voice.
Williams has fought against solar projects for years.
In most places in the world, water is treated and priced like there will always be enough of it. So we end up using it in absurdly wasteful ways.
Californians are now using 18% more water than at the same time in 2017. That's nearly the same amount before the drought was declared. Farmers say they are still working on finding other ways to conserve.
More than ever, we're all looking at how can we get the most out of every last drop of water.
We've been told we have to choose between the food on our tables or the energy in our grids. But what if energy and agriculture didn't have to compete? What if the same land could solve both problems? If the sun that threatens our fields could actually save them? This is SolarRoot. We aren't just installing panels. We are building a symbiosis. By shading the crops, we create a microclimate that protects the soil, reduces water evaporation, and harvests the sun twice. SolarRoot optimizes every drop of rainwater and every ray of light, turning a crisis of resources into a harvest of opportunities. Because the future shouldn't be a choice between power and life.
In Mexico, 76% of consumptive water use goes to agriculture, and globally, 80% of renewable expansion will come from solar. Solar is growing fast, but it's growing in the same land and water that feed us.
As we know, the pressure on land, water, and energy is increasing rapidly, but beyond these numbers, there's also a social impact. As solar energy expands, it competes with agricultural land, affecting the farmers who depend on it. At the same time, water scarcity is limiting food production. Agriculture relies heavily on water and energy, and as these resources become more limited, rural communities face growing economic pressure.
Here we can see the collision that we are facing. Food, clean energy, and water are not competing for the same land. Agriculture is under pressure from heat waves, unstable rainfall, and soil degradation, and volatile input costs. At the same time, solar is scaling fast, but permitting grid connection and storage and bottlenecks, and land demand is a major friction point. Add water scarcity, aquifer stress, and pollution, and you get a single intertwined crisis. If solar expansion displaces farmland, we solve one problem by worsening two others, and that's exactly what we are addressing.
So, how can we make the energy transition truly sustainable?
Here's the core idea of SolarRoot. One infrastructure, two outputs, clean power and food. We keep the solar plant doing what it already does best, which is generate electricity, but we redesign the space beneath it to stay productive. There are three integrated pieces. First, dual-use agrivoltaics. We grow crops under the panel so the land stays in production. Second, we add rainwater harvesting with gutters in a tank to capture runoff from the panels and store it on-site for irrigation. And third, we use smart subsurface drip with soil moisture sensing, so irrigation happens only when needed, cutting both water waste and pumping energy. This isn't just a concept. There's evidence that agrivoltaics can improve crop outcomes and water efficiency. In Oregon, potatoes grown under solar panels showed about 20% increase in total yield compared to potatoes grown in full sun. And in Arizona, an agrivoltaics experiment reported 65% less water loss through transpiration in jalapeno. Our added value is taking that agrivoltaic benefit and making it water resilient by design. We don't just shade crops, we also capture rainwater and apply it with precision irrigation. SolarRoot is flexible, so it can plug into different starting points. For existing solar plants, we add rainwater harvesting and introduce crops underneath with smart irrigation. For existing farms, we installed elevated solar panels above the crops and use the runoff on them as an irrigation source. And for new integrated developments, we co-designed the system from day one so the project is optimized for both energy and agriculture.
Here, we explain what SolarRoots delivers and how we will measure success. First, we reduce land use conflict by producing electricity and crops on the same hectare. Second, we strengthened water resilience with rainwater capture and storage. Third, we cut water waste through soil moisture sensing and automated irrigation, which also reduces pumping energy. Our success metrics are simple: kilowatt hour per hectare and rainwater harvested. This slide is about turning the nexus problem into measurable outcomes: power, food, and using less water. What makes it deployable on real farms? We target shade-tolerant crops, especially leafy greens and tuber like potatoes, where moderate heat can stabilize yields. The structure is designed for mechanization, about 4.5 meters of clearance, plus a safety margin and at least 4-meter corridor for access and turning. On the PV side, we prioritize practical development with fixed-tilt, single-sided models and not bifacial to keep performance predictable over crops. And we use a standard orientation, south-facing, with 40 to 50% PV density to balance generation and crop light.
When we place solar panels over a field, we aren't just adding a power source, we are fundamentally rewriting the laws of that field's environment. This creates a unique microclimate. In this new environment, precision isn't just a goal. If we over-irrigate, we risk nutrient leaking and fungal outbreaks that can rot a harvest before it's even dug up. But if we under-irrigate, the waste stress stuns the tubers and the yield collapses. Therefore, we've got to know exactly when to trigger the system based on the plant's real-time reality. This is where SolarRoot takes over. We've built a nervous system for the farm, from the sensor layer collecting field vitals such as temperature and humidity, to a life-saving drop of water system.
We estimate an implementation cost of the solution between $20,000 and $30,000 per hectare, covering rainwater capture, storage, smart surface irrigation, and control system. This framework applies both to retrofitting existing solar parks and integrating the system into new developments.
We selected the Guajiro Solar Park in Hidalgo as our applied case study, a 130 megawatt installation powering more than 120,000 homes. With SolarRoot, more than 200 hectares under the panels remain productive instead of being displaced. By integrating rainwater harvesting with smart subsurface irrigation, the system captures up to 320 million liters per year, equivalent to the annual water use of 6,000 people. That water supports up to 100 hectares of cultivation per cycle, while maintaining fully renewable energy generation.
SolarRoot delivers more than clean energy. They forge powerful alliances between government, community, and agriculture and energetic industries, enhancing water and energetic resources, doubling efforts all from the same land, merging cutting-edge technology with timeless farming wisdom, building a project with and for the people.
SolarRoot directly advances SDG Target 2.4 by enabling sustainable and resilient agriculture, supports Target 6.4 by improving water use efficiency and reducing water stress, and reinforces Target 7.2 by strengthening renewable energy without land displacement. SolarRoot doesn't choose between food, water, or energy. We redesigned the system so they reinforce each other, because the future isn't about replacing resources, it's about integrating them. So now we ask you the next question. Are you ready to take action?